Hello from my robo. My name is John, and I'm a retired computer technology teacher, now sharing my circuits and learning activities at myrobo.tech. Today, I'm very excited to tell you about my new BEAPER Pico circuit. BEAPER stands for Beginner Electronics and Programming Educational Robot, and Pico refers to the Raspberry Pi Pico family of microcontrollers that it's designed for. BEAPER Pico is the second circuit in the BEAPER family, and it shares the same physical design and overall design philosophy with my BEAPER Nano circuit for Arduino Nano ESP32. Both circuits were created to make it easier for beginners to learn microcontroller programming without having to breadboard and debug hardware circuits at the same time. Each one is simple enough for beginners to use as they start learning to program microcontrollers, and flexible enough to keep supporting learners as they expand their skills learning to program new and different I/O devices. To make learning microcontroller programming even more interactive and fun, both BEAPER circuits were designed to be made into a variety of simple robot projects. I'll give you some tips on how you can make both a really simple robot as well as an amazingly versatile robot with BEAPER Pico later in the video. But first, let's take a look at some of BEAPER Pico's hardware features. BEAPER Pico works with any Raspberry Pi Pico microcontroller, and these have a few advantages and a few disadvantages compared with their Arduino Nano ESP32 counterpart used in BEAPER Nano. I think the biggest advantage of Raspberry Pi Pico over Arduino Nano ESP32 is that the Pico is available in 4 different versions, and each one is less expensive than an Arduino Nano ESP32. This makes Raspberry Pi Pico better for cost-sensitive uses such as schools and robotics clubs. Another advantage is that Raspberry Pi Pico has more onboard I/O pins than the Arduino Nano ESP32, so fewer of BEAPER Pico's circuits have to share microcontroller I/O pins the way they do in BEAPER Nano. One disadvantage of the Raspberry Pi Pico is that only 3 of those I/O pins are capable of analog input, versus up to 8 on the Arduino Nano ESP32. Another disadvantage is that the RP2040 and 2350 microcontrollers used by the Raspberry Pi Picos run slightly slower than the ESP32 microcontroller for many tasks, but raw processing speed doesn't really matter for beginner and educational users. Another difference is that the Picos all use the older and more fiddly micro USB connector instead of the newer and much easier to plug in the right way up the first time USB Type-C connector used by the Arduino Nano ESP32. One more big difference, and one that gave me a few problems, is that the Raspberry Pi Pico module itself is physically bigger than the Arduino Nano ESP32. Since I designed BEAPER Nano first, and I wanted to make BEAPER Pico the same size, fitting the larger Pico module into the same physical space was a bit tricky. I had to go through a few iterations to make enough wiggle room between BEAPER Pico's circuit components and the USB cable running to the Raspberry Pi Pico. Fortunately, getting new PCB revisions made was easy and quick using PCBWay. Every time I had a bunch of changes ready to test, I uploaded the new design to PCBWay, selected the quantity of PCBs I needed, picked the solder mask color, and could instantly see my price. After completing payment, the boards went right into production, and less than a week later, I had a batch of new, high-quality PCBs in my hands. It really couldn't have been any easier. Thanks to PCBWay for sponsoring this video and for providing my initial batch of prototype BEAPER Pico PCBs. Take a look at PCBWay if you need bare PCBs or PCB assembly services, as well as CNC machining, 3D printing, sheet metal fabrication, and even injection molding. You can also check out the shared projects section on the PCBWay website and peruse other people's circuits for inspiration, or order circuit boards for projects you're interested in. I've shared some of my microchip PIC-based circuits there, as well as my original ARPS circuit and the first production BEAPER Nano. Check the description for a discount code that you can use on your first PCBWay order. I recently received my newest production BEAPER Pico and BEAPER Nano PCBs from PCBWay. Let's take a look. BEAPER Pico is designed as a 2-layer, through-hole PCB to make it easy for beginners to build it themselves. In education settings, this lets students learn about electronic components and circuits, as well as practice their soldering skills while they build their own circuit board. BEAPER Pico was also designed to be built in stages instead of all at once, and the assembly instructions will suggest a few common build configurations. The simplest build of BEAPER Pico is referred to as the educational starter configuration. It has just a few resistors, 4 push buttons, 4 LEDs, a piezo speaker, and the Raspberry Pi Pico socket headers. It won't take long for new learners to build this minimal configuration, and with only these parts, beginners can start learning MicroPython programming using the 5 introductory programming activities that I'll be sharing on the myrobo.tech website and on GitHub. MicroPython applies the simple, modern Python language syntax to microcontroller programming, and the introductory activities introduce beginners to input and output operations, time delays, conditional statements, loops, analog input and output, and basic debugging techniques. I'm planning to make a series of beginner programming videos to go along with the introductory activities, and I'll be posting them on this channel soon. If you're interested in seeing beginner MicroPython videos, make sure to subscribe so you won't miss out. After learning the basics of microcontroller programming, beginners can add more sets of components to BEAPER Pico to expand its capabilities. This expandability makes BEAPER Pico really versatile, especially for schools, since it allows instructors to choose which components to install to meet their curriculum goals. Let me expand on that a little bit. BEAPER Pico's flexibility means that teachers can differentiate projects and instruction for groups of students with a range of skill levels and abilities, while only having to stock parts for a single common shared circuit that's been designed upfront to support open-ended programming challenges and project-based learning. Okay, enough of my teacher talk. Let's look at what beginners can do when they're ready to expand BEAPER Pico after learning the basics with the starter configuration. This analog or IoT configuration adds an ambient light sensor, 2 analog potentiometers, digital I/O header pins, an I2C bus quick connector, and this full-color graphical LCD connected to the SPI bus. Beginners can use this configuration to learn analog processing, create user interfaces using the LCD display, attach and experiment with external I/O devices, build simple IoT or Internet of Things devices using the wireless Raspberry Pi Pico modules, and even program old-school video games. There are so many different types of skills that can be developed with this configuration, and there are still more components left to populate on the circuit board. If you remembered that the R in BEAPER stands for robot, BEAPER Pico has a bunch of onboard features that make building robots easy. This robot configuration of the circuit leaves out some of the analog circuitry, but adds the power switch and voltage regulator circuit, 5-volt level shifter and motor driver ICs, this screw terminal block used for connecting a battery and DC motors, and these headers for connecting up to 4 hobby servos. I'm sure you can already see how BEAPER Pico includes everything you need to make a simple robot, but I think the next features are the ones that make it really easy for beginners to build more sophisticated robots. Robots need sensors, and the BEAPER Pico circuit is designed with these built-in breakaway optical sensor modules. They're wired into the main circuit so that each one can be left in place and populated with an LED and phototransistor to become a robot floor sensor, or they can be broken away from the main circuit to make customizing your robot easier. In addition to the optical sensors, the I/O expansion pins on this circuit have been populated with a 4-pin header socket that makes it easy to plug an ultrasonic sonar distance sensor module right in. There's also this I2C bus quick connector that can be used to attach external circuits or sensors, like these time-of-flight optical distance sensor modules. At the beginning of the video, I promised to provide some details on making robots, and the fastest, easiest, and least expensive way to make a BEAPER Pico into a simple robot is to just attach its circuit board, a battery holder, and a couple of motors onto a thin piece of plastic or wood, as I've done here. This one uses 3D printed motor mounts for common plastic gear motors that I'll link below. The left and right optical sensor modules in this robot each contain a single LED and phototransistor to act as a reflective floor sensor. This lets the robot detect the presence or absence of the floor, which should hopefully prevent it from driving off a desk or over the edge of a staircase. A much more versatile and customizable robot uses the 3D printable BEAPER Bot design created for BEAPER Nano and now also BEAPER Pico. All of its parts are shared on MakerWorld, as well as being fully editable in Tinkercad. Since Tinkercad runs in a web browser, and even on Chromebooks, it's easy for anyone, and especially school users, to modify or customize BEAPER Bot's design. The optical sensor modules of this robot have been broken away from the BEAPER Pico circuit and snapped into their own optical sensor mounts. The right sensor module has been populated with 2 phototransistors, so it can become a floor sensor or a line sensor. The spacing of the phototransistors makes it easy to make a line track using ordinary electrical tape. Here I've applied the electrical tape to a piece of white melamine hardboard. The BEAPER Bot chassis uses higher quality N20 gear motors that are smaller, quieter, and use much less current than these plastic gear motors. And all of the chassis parts, including these motor clips and the PCB, snap together without any screws or fasteners. I've already shared a more complete video demonstrating how to assemble the BEAPER Bot chassis and its optical sensors, and it's linked up here. I recently updated the BEAPER Bot chassis design to make it available with or without internal mounts and external openings for optical time-of-flight modules. And all of the BEAPER Bot designs have these dovetail slots that can be used for mounting optical sensor modules or servo modules around the chassis perimeter. The flexibility and ease of assembly of the BEAPER Bot design lets anyone quickly build BEAPER Pico into either a front drive or rear drive robot using a variety of sensors and add-ons. And if you're not interested in making a robot, the versatility of the BEAPER Pico circuit itself can provide a wide variety of options for learning programming, testing new hardware, and for making many other kinds of projects. So that's BEAPER Pico, an easy to assemble and simple to expand circuit designed to help beginners develop fundamental programming skills and continue learning new programming techniques using the Raspberry Pi Pico family of microcontrollers. I hope you can tell how excited I am to share BEAPER Pico with you. Please let me know what you think about it. Is BEAPER Pico something that you would consider using? What would you like to see me do with BEAPER Pico next? I'd love to get your feedback in the comments. If you're interested in building your own BEAPER Pico, I'll have both bare PCBs and PCBs with complete parts kits available, and I'll put the links below. At this point, I don't have complete robot kits available, but if that's something you're interested in, please let me know, and I'll definitely look into that possibility. Thanks for watching, and remember to like and subscribe if you're interested in my upcoming introductory programming and robotics videos. Until next time, keep learning.